Hi, my name is Bill Freeze, and I'm going to be going over the operation of the rush drill and tool grinders. I have three models, the model 250A, 252, and 380. The 250A and 252 have a 3/32 to 2-inch capacity, and the 380 has a 3/16 to 3 1/8 inch capacity. Just want to go over some of the components of the machine and how they operate. You have an in-feed dial here that regulates the movement of the grinding wheel into the tool. This in-feed is graduated in thousandths of an inch, and there's a slip ring on the front for zeroing. The cross feed is here. That's graduated in 2/1000ths of an inch, and that also has a slip ring on it. You also have a vertical movement on the column. That's here. That moves it up and down, above or below center. And there's also a tilt on the spindle. You can tilt the spindle up to 30 degrees. Now the workhead is on a base here. If you loosen the lever, you can swing your workhead to whatever angle you want to grind. The angle scale is down here, and the pointer is right below there to set your desired angle. So for a typical drill point, you would be setting it at 118 degrees. Swing the head over, lock the lever in the front to set the workhead, and then you can grind. There's two modes of grinding with this workhead. One is with the oscillation, that's the workhead going side to side, and the other is just the camming itself. To do the oscillating motion, you have this lever in the back locked and a pin pulled back into place. To loosen that oscillation, you unlock the lever and push the pin up into the workhead, and that locks the head solid, so it's just moving in and out on the cam. For regular drill pointing, you always have the oscillation engaged and a lever locked in the back here. The angle scale here is an included drill point angles. It's set up when the oscillation is engaged that it actually gives you that point angle. So if you set it at 118 degrees for an 118 degree drill point, you get 118 degrees. When you're not using the oscillation, however, all your angles are shifted 10 degrees to the right. So in the case of grinding a 9-degree countersink where you use no oscillation, you would set it at 100 degrees on the scale. We're looking at the components now on the right-hand side of the machine. See, as you turn the crank, you can see the cam rotating here. As that rotates, that moves the chuck in and out to put the relief on the tools. The cams fit on by pushing the head forward and putting the cam on. You use different cams for different number of flutes or for a different type of grind. Slip in there. To increase or decrease the amount of relief on the tools, you move this lever here. There's a lever right up behind the chuck, and there's graduations on the chuck that give you the amount of relief that you're going to put on the tools. So as you move the lever up to a higher number, you get more relief, and as you bring it down lower, you get less. This is the chuck itself. This is a 6-jaw chuck, and you simply put the chuck key in to open and close it. This part here is a setting blade. This is graduated in 1/16 of an inch drill diameter. That's what you use for setting the drill points, and also most of the other tools. That slides right in here. And you also can move this whole setting assembly out of the way. There's a pin right here that you can pull and swing to get the setting assembly right out of the way and for some grinding operations. Also, on the vertical column, you have a scale that shows different height settings. You move it above or below center for special operations, but for normal grinding, you just set it right on 0. That's the center line. Just want to talk about some of the safety considerations on the machine. The first thing to keep in mind is always wear safety glasses or goggles when operating, because a tool can break or a grinding wheel can break or some grit can just get in your eye and cause some serious damage. The other thing to keep in mind is never put your hand in front of the chuck between that and the grinding wheel, because your hand could get jammed in there and cause some serious damage. The other thing too is with the grinding wheels is in case the grinding wheels have been cracked in shipment or there's a defect in the grinding wheel, when starting a new machine or when after mounting a new wheel, when you start it, always stand off to the side in case the grinding wheel should break. You won't get hit with any of the pieces. And make sure that no one else is around in front of it when you start it. Okay, I just want to go over the basic drill grinding right now. First of all, you set the work head to the angle that you want to grind. By loosening a lever here, you can swing the head to whatever angle you want to set. In this case, I'm going to set it at 118 degrees. Lock the head in place here. And for doing the right-hand drills, use the number 4 cam, which fits right on here. And you also use the oscillation on the head. Now, you always use oscillation for drill pointing, and for other operations you do not use the oscillation. The oscillation is engaged by pulling a pin in the back and locking it tight. And that should always be locked tight, because if it is a little bit loose, the head can wobble slightly and cause chatter on the drill. To start setting up, there's several notches here on the work head. You set it in the right-hand slot, a right-hand drill. Put your chuck key in. Put the tool in the chuck and then lightly clamp down on it. Slide in the setting blade from the side here. Rotate the lip of the blade onto the step. You set the drill out by 1/16 of an inch drill diameter. So in this case I have a 1/2 inch drill, so I would set it at 8 position. That should be held right down on there, and then tighten the chuck, pull the blade back, and the drill is set. And you can unlatch, you can see the action you're going to get on the drill. The other consideration here is setting the amount of heel relief on a drill. Now, in our manual we have recommended settings for different size drills and different angles, so you can use that as a guideline. In this case I have a 1/2 inch drill, 118 degrees. I'll be setting the relief drop at 12. That's done by moving the lever here. It's a ball detent, so you have to sort of pop the handle with your hand to make it move into the next hole. So I bring the grinding wheel into position. Bring it in close using the in-feed and cross-feed. Switch on. Then just in-feed as you're turning the crank. Just keep your crank moving at a fairly constant speed. Feeding in about 1 or 2 thousandths for every time you turn the crank. And once you have the drill ground, just turn over slowly and let it spark out. Then move the grinding wheel back out of the way. Turn the motor off and just put your latch right back in this right-hand slot. Take the drill out, and now you're ready to start the next drill. For the taper shank drills, use these rear steadies. You simply put the taper shank in this holder, and that uses as a rear steady. These slide right in the back of the machine, right up through the hole in the back of the work head, and open the chuck. Again, bring the drill out through the chuck and set the lip of the drill out here by 8 by 1/16 of an inch drill diameter, and tighten the chuck. Now, these are namely used for larger drills. Also, if you have large straight shank drills about over 3/4 of an inch, there's a cone type rear steady that you can use also. That slides up in the back and you push the drill in from the front up against the cone inside to steady it. Do a little different type of grind on this drill. It's called a plunge grind. Now this is done if you have a large drill that you have a lot of material to take off, or if you have a drill that's badly damaged. You're going to switch on, bring the drill in until it sparks, then bring the grinding wheel past the tip of the drill, and on your in-feed dial, feed in about 0.10 of an inch. Then you're going to feed the grinding wheel right across the drill. And you just continue doing that until the drill is sharp, and then all you have to do is feed the wheel out a little bit, reset your chuck, and then you can pull it right out the back. This segment we're doing grinding a left-hand drill. Grinding a left-hand drill is pretty much the same as grinding a right-hand drill. The main difference is you use a different cam. In this case, use the #1 cam for 2-flute twist drill. Push the head forward. Slip the cam on, and instead of putting the right-hand slot, you'll put it in the left-hand slot. And in setting the drill up is pretty much the same too. You're going to go out by 1/16 of an inch drill diameter. But in this case, you're going to be rotating the lip up to the setting blade instead of down to the setting blade. So at the same, actually the cutting edge is still level with the step, but it's going to be coming from below. And tighten it, pull it back, and instead of cranking clockwise like you do for the right-hand drill, you're going to crank counterclockwise. When you're grinding the drills, you have to keep in mind the fact that if you grind too much off the drill, you start to change the timing of your grinding. So if you grind too much off, the heel of the drill will start to come up into the air. Now, one way you can prevent that, if you have a drill that has a margin that's badly damaged or it's chipped, you would set the drill out a little further and down a little lower so that you're going to grind back to the good amount of material, and that at that point, that will be the point that you should be setting it on the setting blade. And this eliminates having to reset, but if you can say the drill is broken off and there's really no good reference point, just rough grind it, reset it, and then grind it again. This is the point thinning operation. This is done right after doing the drill pointing. You don't have to take the drill out. You can keep the drill right in the chuck. After you're done grinding, simply index to a green slot on either side of the workhead. You can put it in either one because they're equally spaced. Set the latch in, feed the grinding wheel over to the point thinning wheel, and bring that into position. Where you want to position the drill is set it so that the grinding wheel is not quite on the point but just behind it, so as you feed in, you're feeding it in an angle. So that's going to undercut the point and thin it. If you come straight in, you can just take the point right off the drill. So once you're in position, you switch on. Feed in, thin the point on one side, then zero your slip ring on your end feed. Back it up a couple turns. For the opposite green slot, feed it back into the same 0 point. And then that's equally thin on both sides. This next operation I'm going to go over is called the point splitting. The point splitting is generally done on the heavy web drills like the parabolic and the cobalt drills, and it can also be used on other drills. It helps in centering the drill and also getting the chips out of the hole. The operation is fairly straightforward. First, you have to grind all your drill points. grind them down and sharpen them. Then you do a secondary operation, you split them. So after you've ground your point, you would set the drill up in the chuck. In this case, you're going to use two setting blades. This one is an end stop, slides in the top of the setting plate piece, and then you push the drill up against it and rotate the lip down on the setting blade again. Now this is setting it out a specific distance so that you can repeat when you split each point on the drills. So it's best when you're doing this is to grind all the drills and then set them up, starting with the smallest drill and working up to the largest drill. But you can do all sizes in one setup. And you pull back. That's set. And that's in the right-hand slot the way you would normally set up. As far as the angle of the workhead, this is going to be set up at 170 degrees on the left-hand side of the scale. You do not use the oscillation. You lock the oscillation out, push the pin up in the head, and loosen the knob in the back. The vertical column is going to be dropped down below center. Looking on your scale, bring this down to 55 below center. Now bring the grinding wheel into position. When you have this roughly in position, you would index to the number 11 or the number 5 slot. There's 12 equally numbered slots on the workhead, and so the opposites are always 6 apart. So you can start on either side. Line the edge of the grinding wheel up with the center of the drill point. And switch on. Then looking down from the side, feed in. So you've gone approximately halfway across the web of the drill. Then set your slip ring to 0. Back it out a couple turns. Index to the opposite slot. And just feed it back into 0. Now at this point, you'd want to flip back and forth and check to see if you've ground enough. It's best on the first pass is not to try to grind it all at once, because you may go past center and then you're going to oversplit the drill. So I've got to bring in a little bit more here. So I'm bringing a little bit more. Flip to the other side. Feed it back in the same point. Again, establishing your 0 point with a slip ring. Check that out. If you have it split to center, then you've gone through the initial setup and you're set to grind the next drill. You simply switch the motor off, feed the wheel out, set it in the right-hand slot, take the drill out. Okay, and now to put the next drill in, you would simply put it back in the same position that you had before, pushing the tip of the drill against the setting blade and rotating the lip onto the step. Indexing to number 11 or 5 slot. And feed it into 0, back it up, go to the opposite slot, and feed it back into 0 again. And each drill you'll have split to center. Now you're going to have a little bit of wheel breakdown with this. That's why in this case I've used a 100 grit wheel. It's a finer grit wheel, or you can use also, in some cases, a Borazon wheel, and that'll hold the sharp corner on there. You can probably, with a 100 grit wheel, you could probably run 20, 30 drills before you'd have to dress. And after you've done about 5 drills, it's best to probably feed in 1/1000ths more on your dial feed to compensate for the wheel breakdown. I'm also using a smaller diameter wheel recommend using something around 5.5 or 5 or 6 inches in diameter. This will give you a steeper cutback on the drill when you're point splitting. On the Model 380, there is no end stop for setting the tip of the drill, so we recommend setting it at 30 on the scale. Okay, this next operation is going to be the web thinning. Now, web thinning and also lip correction, as going across the cutting edge, are done very much the same setup as point splitting. Usually in this case, your drill, so you drop the grinding wheel down below center. You can use the regular type grinding wheel, although again, the finer grit, smaller diameter wheel like you use in the point splitting may work better. If you're doing a larger drill, such as 1 1/8 drill I have in the chuck, you don't have to set the drill out further again. In a lot of cases, you can do it at the same time you're grinding the drill. You simply finish grinding the drill, drop your grinding wheel down below to 55, and then swing your grinding head over till the locating pin drops in the hole in the center. Just put the pressure down on the pin as you swing it over. Then all you would do would be, for the web thinning, would be an index to the number 10 slot instead of number 11 like we did for the point splitting. If you have smaller drills, you do have to set them out at the end so that you have enough clearance between the grinding wheel and the workhead. So we'll switch on. Zero your slip ring, index 180 to the number 4 slot, feed back to 0 point. Now the amount that you want to thin the web should be approximately 1/10 of the diameter of the drill. So it's best to probably take, if you have a real thick web drill, is to take a few passes. Don't try to take it all off at once. You'll get too much of a radius on the wheel and could burn the drill also. To do the lip correction, you would simply index over to the number 3 or the number 9 slot. And that does is line the cutting edge so it's straight up and down, and then you can feed the wheel in and cut across, thin the web and go across the cutting edge. If you're going to be drilling in, say something like brass, you want to have a zero rake or a flat edge, you would have the wheel head in straight. For most materials though, you'd want to set your workhead over at about 170 on the left hand side of the scale. Lock that in place and then go in and feed, and that is going to put a positive rake on the cutting edge. And when you grind, you want to grind enough off so that you leave a ledge below the cutting edge. It's like a sharp angle formed by the grinding wheel, and that allows the chip to come off the cutting edge and hit that step and curl back and break. So that's what we use for chip breaking if you've got some material that's very stringy and you're having trouble getting the chips out of the hole. This section is showing the grinding of core drills. Core drills are done a bit differently than a regular drill. First of all, you have to change the cam for a different number of flutes. In the case of a 4-flute core drill, which I'm going to show now, you use the number 8 cam for the right hand, and you'd use the number 7 cam for left hand. To set up and grind a right hand core drill, you'd first put the latch in the right hand slot, and rotate the lip of the drill onto the setting blade. Now with the core drills, you do not use the oscillation. They're simply having the in-out motion of the cam. So you lock out the oscillation. That is, you push the pin up into the workhead and loosen the knob in the back, and then set your lip to any place that you want to set it, any place that's convenient. As far as the cam relief, you would set that at about 10, 12 on the cam drop, and the angle you want to set it at for most core drills would be not at 118, but set at 10 degrees further to the right. It's 128. Now the reason you don't set it at 118 has to do with the oscillation of the workhead. When you're using the oscillation, and again the swinging back and forth of the workhead, the actual angle that you want is you set on the scale. So you want 118, you set it at 118. If you want 90, you set it at 90. If you're not using the oscillation, the workhead comes up to the wheel a little differently, and you want to set it at 10 degrees to the right of whatever your setting is. So in this case, 128 degrees is 10 degrees to the right of 118. So with that set the angle, set the lip of the drill, set the relief, ready to grind. Type of drill, you just grind the same way as you would a regular drill, and you can, if it's badly damaged, use the plunge grind as well. When you get done though with grinding the core drill, usually you should also face these drills. So to do that, you would swing the workhead over till the pin drops in the locating hole so that the tool is in straight. Then remove the cam so the workhead is just spinning. And just face the end flat again. This is showing the operation of grinding the 3-flute core drills. This would be on the 250A and the 380. The 252 is done a little differently. Use the number 10 cam for grinding the 3-flute core drills, and also the 3-flute taps. This is also used for 6-flute tools. So load the cam on. Again, set it at 128 degrees. Right hand slot, about 10 or 12 on the cam relief. Set the lip out wherever you want.